Have you ever looked up at the night sky and felt a sense of wonder? Countless stars blanket the darkness above us. A faint milky band stretches across the heavens. This is the Milky Way, our galactic home. A vast collection of stars, gas and dust. It is a place of immense beauty and mystery. The Milky Way may seem like a distant and unreachable realm, but it is a place of incredible importance. It is our cosmic cradle. The Milky Way is where our sun was born. It is where our solar system formed. It is where humanity took its first tentative steps into existence. The Milky Way is a barred spiral galaxy. Imagine a giant cosmic pinwheel, its arms swirling through space. That is our galaxy. At the center of the Milky Way lies a supermassive black hole. A region of intense gravity, it holds the galaxy together in a delicate cosmic dance. Our sun is located in one of the Milky Way's spiral arms, the Orion Arm. It is about 2/3 of the way out from the galactic center. The spiral arms of the Milky Way are not static structures. They are constantly moving like waves on a cosmic ocean. The Milky Way is home to a staggering number of stars. Hundreds of billions of them blaze throughout the galaxy. These stars come in a dazzling array of colors and sizes. Some are small and faint, barely flickering against the cosmic backdrop. Others are giants, burning brightly and casting their light across vast distances. Within the Milky Way's spiral arms, clouds of gas and dust provide the raw materials for new stars to form. These stellar nurseries are places of intense activity, where gravity pulls together matter, igniting the fires of nuclear fusion. At the very center of the Milky Way lies a region of extreme gravity. A supermassive black hole millions of times the mass of our sun lurks there. This black hole is a powerful engine driving the dynamics of the galaxy. Its immense gravity warps the fabric of space-time, creating a region of intense energy. The supermassive black hole at the center of the Milky Way is not a destructive force. It is an integral part of the galaxy's evolution. It helps to regulate star formation and the overall structure of the Milky Way. A galaxy of wonders. The Milky Way is filled with a menagerie of celestial objects. Nebulae, glowing clouds of gas and dust, light up the galaxy with their ethereal beauty. Star clusters, groups of stars bound together by gravity, glitter like cosmic jewels. And throughout the Milky Way, planets orbit their parent stars, just as our Earth orbits the Sun. The Milky Way is a place of constant change and evolution. Stars are born, live out their lives, and eventually die, sometimes in spectacular supernova explosions. These cosmic events enrich the galaxy with heavy elements, providing the building blocks for new generations of stars and planets. The search for other Earths. In recent decades, astronomers have made a groundbreaking discovery. They have found evidence of planets orbiting other stars in the Milky Way. These extrasolar planets, or exoplanets, come in a wide range of sizes and compositions. Some are gas giants, larger than Jupiter, others are small and rocky, like our own Earth. The discovery of exoplanets has profound implications for our understanding of the universe. It suggests that our solar system is not unique, that planets and perhaps even life itself may be common throughout the cosmos. Are we alone? The question of whether or not we are alone in the universe is one that has captivated humanity for centuries. The sheer size and scale of the Milky Way, with its billions of stars and countless planets, makes it seem statistically improbable that we are the only intelligent life in the galaxy. While we have yet to find definitive proof of extraterrestrial life, the search continues. Scientists are using a variety of methods, from searching for radio signals from other civilizations to looking for biosignatures in the atmospheres of exoplanets. A galaxy is born. The Milky Way galaxy, like all galaxies, formed billions of years ago. This process was not instantaneous but rather a gradual evolution that spanned eons. Its origins can be traced back to the early universe, a time when the cosmos was a very different place. The universe was young, chaotic, and filled with potential. In the aftermath of the Big Bang, the universe was filled with a hot, dense soup of particles. This primordial state was the birthplace of everything we know today. Over time, this soup began to cool and expand. As it did, the fundamental forces of nature began to shape the universe's destiny. Within this expanding universe, tiny fluctuations in density began to grow. These fluctuations were the seeds of future galaxies. These fluctuations, seeded by quantum mechanics, provided the gravitational seeds for galaxies to form. Quantum mechanics played a crucial role in determining the structure of the universe. Over millions of years, these seeds drew in more and more matter, gradually assembling into the majestic structures we see today. The process of galaxy formation is a testament to the power of gravity and the intricate dance of cosmic forces. Within these forming galaxies, stars began to ignite, creating stellar nurseries where new stars were born. These stars would go on to form the building blocks of galaxies. As galaxies evolved, they often collided and merged with one another, leading to the complex and diverse structures we observe in the universe today. These cosmic collisions played a significant role in shaping the Milky Way. The Milky Way itself is a barred spiral galaxy, with its iconic spiral arms and a dense core. Its structure is a result of billions of years of cosmic evolution. Dark matter, an invisible and mysterious substance, also played a crucial role in the formation and stability of galaxies. It acts as a gravitational scaffold, holding galaxies together. The story of the Milky Way is far from over. As the universe continues to evolve, so too will our galaxy, continuing its journey through the cosmos. Observing the Milky Way in the night sky, we are reminded of the incredible journey that led to its formation. It is a testament to the beauty and complexity of the universe. The invisible hand of dark matter. While we can observe the stars, gas, and dust that make up the Milky Way, there is much more to our galaxy than meets the eye. The Milky Way, with its billions of stars and vast clouds of gas and dust, is just the tip of the cosmic iceberg. In fact, the vast majority of the Milky Way's mass is made up of a mysterious substance known as dark matter. This enigmatic material doesn't emit, absorb, or reflect light, making it invisible and detectable only through its gravitational effects. Dark matter does not interact with light or other forms of electromagnetic radiation. This means that it doesn't shine like stars or glow like gas clouds. Instead, it lurks in the shadows, influencing the universe in ways we can only infer. We can infer the presence of dark matter through its gravitational effects on visible matter. For instance, when we observe the bending of light from distant stars and galaxies, a phenomenon known as gravitational lensing, we are witnessing the invisible hand of dark matter at work. The rotation of galaxies, including the Milky Way, cannot be explained by the visible matter alone. If we only consider the stars, gas, and dust, the outer regions of galaxies should be flung apart due to their high rotational speeds. There must be some unseen mass, providing the extra gravitational pull to hold these galaxies together. This unseen mass is dark matter, and it acts as a cosmic glue, binding galaxies and galaxy clusters, shaping the large-scale structure of the universe. Computer simulations of the universe show that dark matter forms a vast, intricate web, with galaxies and galaxy clusters residing in the densest regions of this cosmic web. Without dark matter, the universe as we know it would not exist. Scientists around the world are working tirelessly to understand dark matter. Experiments deep underground in space and in particle accelerators are all part of the quest to detect and study this elusive substance. While we have yet to directly detect dark matter particles, theoretical models and indirect evidence continue to guide our understanding. The search for dark matter is one of the most exciting and challenging frontiers in modern astrophysics. As we gaze up at the night sky, we are reminded that the universe is full of mysteries waiting to be uncovered. Dark matter, though invisible, plays a crucial role in the cosmic dance, shaping the universe in ways we are only beginning to understand. Our place in the cosmos. From our vantage point on Earth, we have a limited view of the Milky Way. We see it edge on, as a band of light stretching across the night sky. But if we could travel outside of our galaxy and view it from afar, we would see a majestic spiral structure, its arms swirling around a central bulge. Our Sun and solar system occupy a relatively unremarkable position within the Milky Way. We are located in one of the spiral arms, about halfway out from the galactic center. Our neighborhood of the galaxy is not particularly dense with stars, nor is it particularly empty. A cosmic carousel. The Sun, along with all the other stars in the Milky Way, is constantly in motion. This motion is not just a simple path but a complex dance through the cosmos. It orbits the galactic center, completing one revolution every 230 million years or so. This journey is known as a galactic year or cosmic year. This means that since the formation of our solar system about 4.6 billion years ago, the Sun has orbited the Milky Way approximately 20 times. Each of these orbits has seen the solar system traverse through different regions of the galaxy, each with its own unique characteristics. As the Sun orbits the galactic center, it bobs up and down like a horse on a carousel. This vertical motion is a result of the gravitational forces exerted by the dense disk of stars and gas in the Milky Way. This is due to the gravitational influence of the other stars and gas in the Milky Way. These gravitational interactions are complex and dynamic, constantly changing as the Sun moves through different regions of the galaxy. These movements through the galaxy expose our solar system to different environments, which can have an impact on the evolution of life on Earth. For instance, passing through regions with higher concentrations of cosmic rays could influence mutation rates and evolutionary processes. Additionally, the solar system's journey through the galaxy can affect the climate on Earth by altering the amount of cosmic dust and interstellar material that reaches our planet. Over millions of years, these cosmic interactions have played a role in shaping the history of our planet. From ice ages to mass extinctions, the solar system's path through the Milky Way has left its mark on Earth. Looking ahead, the Sun will continue its journey around the galactic center, and our solar system will encounter new cosmic environments. Understanding this cosmic carousel helps us appreciate the dynamic nature of our place in the universe and the ever-changing conditions that have influenced life on Earth. The cosmic carousel is a reminder of the intricate and interconnected nature of the universe, where every star, planet, and galaxy plays a part in the grand cosmic dance. A dance with Andromeda. The Milky Way is not alone in the universe, it is part of a group of galaxies known as the Local Group. The largest galaxy in the Local Group is our neighbor, the Andromeda Galaxy. Andromeda is another spiral galaxy, similar in size and structure to the Milky Way. In about 4 billion years, the Milky Way and Andromeda galaxies are destined to collide. This cosmic collision will be a slow and drawn-out affair, lasting for millions of years. As the two galaxies merge, their gravitational fields will distort each other's shapes, triggering bursts of star formation and creating spectacular displays of celestial fireworks. Our galactic legacy. The Milky Way galaxy is our home in the universe. It is a place of immense beauty, wonder, and mystery. From the supermassive black hole at its center to the countless stars that populate its spiral arms, the Milky Way is a testament to the power and creativity of the cosmos. As we continue to explore the Milky Way and beyond, we gain a deeper appreciation for the interconnectedness of all things. We are part of something much larger than ourselves, a cosmic story that began billions of years ago and continues to unfold today. If you love space facts, hit that like button and subscribe for more cosmic wonders.